morning to all of you. And guys, today our topic is welding. So, uh, welding means uh, it is a process where two metals and two parts of metals are joined together by another metal which will fill, or sometimes filler is not available or filler is not applied. Two metals are joined together. This is the main aim of this welding. But as an electrical engineer, we have to, as in, we have to know the how the welding is done and how much electricity power consumption are required generally. And this is our main topic for our welding in utilization process. We have to know, as per our syllabus, we have to know the type of welding and and which how many types of welding are there, a little bit the information about the process, and the additionally I will show some type of joint. This is not included in your syllabus, but for the betterment of your preparation for any gate or any competitive level exam, you have find some question which is related to the welding thickness, and so many times I have seen this, and that's why I think that I have to share some knowledge is regarding the regarding some joint, special type of joint, okay, which are used in welding. So let's start. First, welding is divided into two ways, and I think, oh, as an electrical engineer, that you have seen so many times this welding, because in your workshop, you have seen this. You have seen any welding area. There is some sparks are coming out from the welding, and some sounds also coming out, and then the filler metal became melted, and it will fill the two joint between the two joint, and it will just join with the total metal. Okay, so generally welding are uh, divided into two categories. Actually, uh, many way uh, you can categorize this welding, but now we can say that is solid state welding, and another is fusion welding. What is fusion welding? Statistics means here some electrostatics, or some two metals are joined together, but not using some arc, or some fusion are not there, because two another metal are not joined here. But in the fusion welding, there is two parts of metal are joined, and generally same parts of metal are joined, and the uh, same metal are coming together near, and then we fill some filler metal, uh, and then after it became cool, then it's joined the two parts of this metal. This is the main motive of this fusion welding. Look, here is some differentiation. Look, autogenous welding, no filler metal are there. Okay, then what happens? We apply some, we apply some heat and pressure. Then two parts of the same metal are joined together. When the edge of this metal became just plasma state, and it will join. Okay, and then homogeneous welding. What is this? This is the filler material of composition same with the base metal. Means the two basic base part are the same metal, and the homogeneous जो filler metal है वो भी same है. तो इसको homogeneous metal. और heterogeneous क्या होता है? Actually heterogeneous welding is that where the filler material of the composition different from the base metal. Now in this scope I have to say something about the filler metal. Look, some base metal which is generally really iron or maybe copper is there, but filler metal is generally used, which is lead free. Generally we are using for this welding purpose, for the welding purpose, not soldering purpose. Soldering purpose we are using lead, also lead and tin we are using, but in brazing we are using generally brass type metal, and you may say this is the generally brass, and this is soldering purpose. We can use anything, just like the aluminum, just like copper, just like iron, but generally we are using uh, lead free, cadmium free, etc. And this will be decided by the American Welding Society. Okay, American Welding Society is some given some specification which type of filler metal we can use, and as per this guideline, and ISO also follow these guidelines. So there is something, but the main motive of this welding filler is that there is lead free and cadmium free. Okay, so this is the overview of welding in categories. And now another way we have to know. Look, here also this type of things are there. Same things. Filler is homogeneous or heterogeneous, and without filler this is autogeneous. This same metal are joined together. Okay, and widely we can categorize this welding process. Here is some details of the welding process, and somewhere the type is not just like this. Here you can see the five types of welding categories are divided, but somewhere it is generally broadly classified into two ways. First one is fusion welding, and second one is pressure welding. Means in fusion welding there is no pressure are generally used. Okay, simple filler metal are used, and it have to reach the melting point. And the pressure welding is just like two metals are coming together, and it will be pressurized back to back, and some heat also provided here. Then the edge which are connected each other, this edge became just like a plasma state, not melted but plasma state, just sticky type state, and then it will just join, and then if we cool it, it became just like a joint metal. Okay, so we can find in this way we also define we also categorize in two way: fusion welding and pressure welding. And fusion welding, under this fusion welding, you can see this is also shown here, but I will explain. But in fusion welding, you can categorize both of these, just like arc welding, in oxy-fuel welding, which is called the gas welding. In here, oxygen as used as a fuel. Generally in motor garage, in a cycle garage, you have seen they are using some cylinder and using some two gases. Two pipes are there. This is oxyacetylene. Okay, oxygen, acetylene, and somewhere it is, look, here is a gas welding is there. This is also coming under the fusion welding. Okay, this gas welding also oxyacetylene, air acetylene, oxyhydrogen also there. So we have generally seen this is the oxyacetylene gas are used. Okay, then laser beam welding. Laser beam also just like this. Here is, you can see some laser also there. Here, newer welding means upcoming. This is the laser. Okay, it is also coming under the fusion welding. In hermit welding, in a railway track, so many times you have shown on that there is a fusion type hermit welding as done there. Okay, and in this type, you have seen, and if you categorize again this arc welding, then you can see that this is the electric arc shielded metal arc welding. What is this electric arc? Okay, a gas metal arc welding. You can see here, uh, gas metal arc welding. This is MIG, MIG. Okay, and gas tungsten. arc welding. I will one by one I explain everything. Okay, because it is very much interesting, and if you know this, is sometimes so many questions, tricky questions are coming. Which type of gas? How many temperature? This is okay, and so many you can say plasma arc welding, gas tungsten welding. Um, these are here, and another welding which is related to resistance welding means it is done by the resistance. Is how many resistance is there, and if resistance create temperature, and then it will melt the filler material or your the metal. This is the butt welding, spot welding, seam welding, and some projection type welding. Okay, and you have seen that's a newer welding. This all are coming under fusion type welding, and this is the solid state welding. Solid state welding coming under the uh, this is coming under the pressure welding, where pressure are used. Look, this is friction, ultrasonic, diffusion, and explosive type welding. Okay, so uh, in generally arc welding needs some electric power, and solid state welding also needs some electric power. But the thermit welding, which is under the arc welding, it's no need of the electricity. Okay, because on the railway track you never get some electricity which is applicable for your normal manual use purpose, because uh, everywhere electric electric traction are not available. Mm. But at that moment, some thermit type weldings are there. Somewhere you have seen in your railway track is thermit welding are there. Now I am going to talking about arc welding. Okay, this is our first topic, and we have to know details because here electricity is done here. Now, one questions or one discussion is there. How many types of welding are there? Generally, broadly, if you categorize in about basic things on temperature, then it is three types. First, this is the low temperature, medium temperature, high temperature. Low temperature means soldering. What are we are doing in our electronic circuit, right? Or normally in our circuit, this is the normal soldering. This temperature is generally 420 degree to 450 degree centigrade. Low temperature. Sorry. This is not soldering. Soldering it is 110 degree centigrade maximum. Okay, and if you go for the brazing, next next is the brazing. Brazing it is under 420 degree centigrade to 450 degree centigrade. Okay, brazing is just like a brush leads it there, and if you melt it by applying some electric connection, and it will causes 420 degree centigrade to 450 degree centigrade, and then it will be melted. And this brush is just put under some grooving of two metals, and then it will join. And then, and if we go for the high level welding, this is arc welding, another welding, this is causing, I think, at least the if you go for high temperature, then it will causes is 6500 degree Fahrenheit. Okay, the temperature is 6500 means it's 6500 degree Fahrenheit. I am not saying about centigrade. Previously, I told about 450. This is brazing, meaning it is under centigrade, but now it is a Fahrenheit. So this amount of temperature is created. So this is the welding, arc welding. And now you can see what is the mechanism of the arc welding or working process. Look, here some power section is showing there. There is some positive, negative, or you can say neutral uh, line. So what happens? Here is a wire is going there, and this is the arc rod. in this arc rod we are using the filler metal. Okay, and this is the workspace in which two metals are joined. Where another wire is just attached with this, or it may be attached with a table, or this is a soldering table, maybe soldering table, or directly you can use with this metal, work metal. And now whenever this whenever this arc rod is just coming to near this area, generally it should have some difference. If you directly touch it, the arc will closed because the circuit is completed, then some sound is there. You can't touch it, you have to put some distance. Generally a 5 millimeter distance is there, then it will causes some arc. Arc means if you put some positive voltage at a electrode, if you put some negative voltage at automatically connected zero, uh, then what happens if two electrodes are coming together near, not touch, then what happens there creates an arc, just like a spark. Whenever we switch off our switch, then you have seen some sparking. This type of sparking are there. The here is the sparking amount is high, that's why we are getting some high lights, and it creates some high temperature. This temperature is 6500 degree Fahrenheit. I am saying this is the Fahrenheit. Then what happens, this arc rod, it is actually a filler material with coated with some flux, then it will melt, and whenever it is melt, it will just slagged over the grooving or between these two parts of this metal. And whenever you completed it, whenever it's became just chilled or cooled, then what happened, it's joined two parts of this metal. This way we can use this arc welding. Okay, now some interesting topic. Arc welding, this is done by ampering, means here high ampere is required, means mainly 10 10 ampere is required. So what happens, we are using some 10 ampere currents over there. Just remember 10 amperes or around to 10 ampere, maybe 15, maybe low. But sorry, but what happens whenever we ampering, means we are in local language it is called ampering. Actually ampering is not a good language or any you can find in any book, but in industrial purpose, uh, I have listened to this word, that's why I'm saying. Ampering means we are step down the voltage. So if we step down the voltage, then ampere will be high because P1 equal to P2. So secondary portion is P2, then ampere will be high and the voltage will be less. So in this case, what happens? Voltage became very low. So in this case, you never get shocked. Okay, so this is the thing. Ampere is high, but voltage is very less. So, anyway, if you touch something, you will not shocked. Okay, this is the main local language, but don't do this. Don't taste it. Uh, it is the main, but we are using this with the gloves, with the goggles. Okay, because voltage is very slow. This is the just like just take it as a story. Not try to use this or don't practice it. This is a un this is the unauthentic phenomenon which is happens with the industry and practice, and that's why I'm saying it. Okay, and this is the main things ACDC, whatever you can use. And now I am going to the differentiation of uh, this arc welding. Now you can say this is carbon metal arc welding, but actually the the weldings are differentiated it in different way. That is, you can say this is MIG welding, metal inert gas welding. Okay, metal inert gas welding. Look, here is some filler metal is there and some inert gas also used. Why inert gas or gas? And next time you can say, you can see the metal active gas welding. This is called MAC. Okay, but why gas are used in metal? Look, whenever high temperature is used, what happens? There is some uh, ionization, ozone gas, and some chemical reaction is occurred with the atmospheric gases, and it may causes some difficulties, and that's why some inert gas or some active gas are used so that the atmospheric gas could not come together with this filler material or here. So it will not create any harmful. And after cooling, and then it will just like a inert and no oxygen, sorry, nothing will create any things. Okay, and guys, here's some Uh, now I have to say something about the arc welding. Look, arc welding is a type of fusion welding. Hope you can understand which is a fusion type. Arc welding is a type of fusion welding process by using some electrical arc to create heat to melt a joint metal and joints metal. Look, you can see here some sorry, here some a power supply are given here. And now electric arc between a consumable or non-consumable electrode and the base material using in the either AC or DC. So you can use AC, you can use DC. Okay. At the arc welding, generally 6500 degrees Fahrenheit, right, instant heat will be created. Instant means it will uh, uh, not stay for the long time, just for few seconds only, and it will create some melting of metal, and this melted metal will fill the gap between these two parts of this metal, and after cooling out, then it uh, became a single metal, because a single piece, not metal, because this filler just joined these two parts. Okay, and now as the metal, why inert gas or active gas are used? Look, as the metal reacts chemically with oxygen and nitrogen, because high temperature is there, high temperature at this moment. So in the air, when heated at some high temperature, it will be some reaction will be there. So a protective shield and protective shielding gas are used on this slag so that it minimizes the contact of this molten metal with the air. Once it became cooled, the metal just solidified, and it's formed the metallurgical bond. First thing is the metallurgical bond. Okay. Now we can categorize this arc welding in uh, anyway, but which are very much the renowned process. These are, first is consumable electrode method. It is coming under consumable electrode method. So under this, the metal inert gas welding. This is called MIG, metal inert gas welding. Means when you put metal in this arc welding, just like this, in this arc welding, the filler metal are melting and it is filling. But what happens? Some inert gas uh, um, just surrounding this area, some inert gas are used to cover up, so that, or you may say this is for shielding, so that the nitrogen and oxygen not come in contact with this filler material. Then it will create some chemical reaction. So it will, we use some inert gas. That's why this is called MIG welding. Okay, or something gas metal arc welding. This is called, and this is very much renowned for MIG welding. Another welding is that mag welding. In this mag welding, same things are there, same arc is happens, but here is some active gas, means not inert gas. This is normal active gas are used. This gas generally we use as a flux, because if you use, then what happened? The temperature rise here. Okay, so this is the just difference MIG and mag. Now I am going for the shielded metal arc welding. In this portion, some shielded metals are used. This type of metal are used in various cases. You have find it. Some shielded metal are used, so that the others. This is actually the made of flux. Okay. So what happens? The other chemical reactions are not happens with this just melted at a high temperature molten metal. Okay, this is the things. And another way, this is the submerged arc welding. Look, what happens? You have seen there is some splattering, there is some high temperature creating, and high spark is there, and ozonization is occurred also there, because blue type of lights are coming, and some ozone gas are created over here. So the operator or the welder who using this process is his health and his eye is very much affected. So he or she need to be get some protection. But in submerged process, if we submerge with some flux, look, in this way you can see that this is done under some flux material are there, it is covering there. So what happens? Splattering, lights and ozonization, this type of things are not happens. It is because we are submerged this process under some flux material. Flux material will just burn out, but it will under this material, so that no splattering in light and other things are not coming out from this slags. Okay, this is the main difference of this submerged arc welding. Okay, and another topic is here. This is also coming under the submerged electrostatic material, that is coming from electrostatic or electro slag welding. Look, in this case, what happens? In this case, some metal are some electrons are coming out from this material. Whenever electrons anode cathode ionization is there, at the at that moment some metal are melted and it will join together. This is the main concept. Okay, and another type of materials are there, and that is arc stud welding. This is called SW, and this is the main fusion type material. And I think uh, whichever I have told, this is coming under arc material, sorry, arc metal welding. And next topic, I will one by one, and I will explain everything. That's a short process. Yes, I will explain. And there is so many differentiation is there. We have to know which are the process. If you go for the pressure welding, you can find out there is some welding process. First one is resistance welding process, friction welding process, diffusion welding process, ultrasonic welding process, cold pressure welding process, explosion welding process, and forge welding process. This is coming under pressure type welding where we don't use any arcing. Okay, we just pressure and get some. We use some pressure and apply some heat so that it became joint. And the resistance welding, this is you have as an electrical engineer, then you can find that the resistance is the common things. So we want to know much about this resistance welding. So today we are just saying about which type of resistance welding are there. It is the spot welding, film welding, projection welding, butt welding, okay, and flash welding, and uh, another welding is there, percussion welding. Okay, if, I think I will explain this resistance welding one by one. Uh, it will help you for your future. I think so. Today, I think I class is over. So I close this. Next day, I will explain total resistance welding, the total process, temperature used, etc. Okay. Okay. Thank you, guys.